All right, we are back. Now we are going to learn to read and write in scientific notation. You have two notes today. The first one is reading. Normally I don't go over them, but there are some important parts, and then we'll get to the examples. The second part is writing. So again, gonna go over the notes just quickly. Couple of things that I want to point out to you. I already spoke about why we use scientific notation, so I'm not going to go over that. I just want to point out a couple of important things when it comes to scientific notation. I told you yesterday it's a product of a factor and a power of 10. So the factor has to be a number that is greater than or equal to 1, but less than 10. On this page, on your second notes, I wrote between 1 and 9.9999999 repeating, okay? It cannot be 10. It cannot be 0.9. It has to be either 1 or more, but 9.9 is, or 9 is the highest that you can go, okay? The power of 10 can be positive or negative. We talked about that yesterday. If it is a positive exponent, then it is a large number greater than 1. If the exponent is negative, then it is a very, very small number, less than 1. You're looking at decimals. All right. So the first couple are just some examples of ways that kiddos generally write scientific notation. So this is proper scientific notation. Yesterday when we were estimating, it was just a single digit. But technically, you don't drop off parts of the decimal. You leave the whole thing. The only thing that you really drop off are the zeros. So if the decimal, if you're rounding, then obviously you're going to drop off the zeros. But if you're not rounding, it's just a very, very large number. You keep all of the digits that are, oh, what's the word they use? Significant digits. So this is proper scientific notation. That number is between 1 and 9.999 infinity. And this is times a power of 10. This one is not, because this number is less than 1. 0.25 is less than 1. So this is not proper scientific notation. You would need to bring the decimal over one more time and also then change the exponent. You can never move a decimal over here without making an adjustment over here. We'll talk about that when we get into adding, subtracting, multiplying, and dividing. This is also not proper scientific notation. 12 is greater than 9.999999999. So you would have to move the decimal to the left and again make the adjustment on this side. So please, 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 none of this, none of this. That is not proper scientific notation. 1 and 9.999999999. The other thing that I wanted to point out on the notes, if the exponent is negative, so if you have a number that's given to you in scientific notation and you're needing to write it full out, standard form is what that is called. If the exponent is negative, you're moving the decimal to the left. If the exponent is positive, you're going to move it to the right. So in these examples here, I tried to write it out kind of in steps. So you have 4.5 times 10 to the 7. So because this 7 is positive, we're going to move the decimal right 7 times. So you can see that I did that here for you. 1, 2, 3, 4, 5, 6, 7. What goes in all these, I call them loop-de-loops. I don't know. Or use, I guess. I don't know. What goes in all of them between the last digit and the decimal is just zeros. And then you just rewrite the number, add the commas where they go. Remember, every 3 place values is a comma, because that's a new, oh my gosh, I'm totally blanking on what that is. That's fine. I want to say domain, but I know that's not right. This is the hundreds, this is the thousands, this is the millions, and there's the billions. Maybe it is domain. Who knows? I don't know. So here we have 6.25 times 10 to the negative 5. So because it's negative, we're going left. Okay. And we have to go left 5 times. So I did that for you here. We went to the left 1, 2, 3, 4, 5. Same thing applies here. All those empty loop-de-loops, get a 0. And then you just rewrite it. This 0, I put a little tiny note here for you. This is kind of just a placeholder. It draws attention to the decimal. It doesn't really count in this, in your exponent. It doesn't count here. It just kind of draws attention to the fact that there's a decimal behind it. So you just kind of add it on. This is the number in scientific notation. This is what I call the attention grabber 0. It doesn't really count towards anything. So there are 2 here that you can try on your own. I'm going to switch over to writing numbers in scientific notation, and then we're going to actually go and do it in the book. Remember 1 and 9.9999999 infinity. If the number is positive, if the number is greater than 1, you're going to move that decimal. Holy cowbells. If you move the decimal left, the exponent is positive. If you move it right, the exponent is negative, but I like to think of it more as if the number is greater than 1, the exponent is positive. If the number is less than 1, the exponent is negative. So I kind of wrote it out for you down here in teeny tiny little handwriting. And then this one, I kind of just did it shorthand. So the first thing you're going to do is move the decimal until you get a number between 1 and 9.999999999. So we moved it. Let me get my pen because my fingers are a little chunky on this here thing. So we moved it 1, 2, 3, 4, 5. Remember in the last example, I said we can't stop here because this number is not more than 1. We had to go one more place value. 5 is in between 1 and 9.9999999. So 5.61 is what we're going to keep. That's the factor. 5.61 falls in between 1 and 9.9999999. Oh man, this is what happens when you stay late recording videos. The lights go out. But it's okay. I love you. That's why I do it. All right. So then, how many times did we move it? We moved it 6 times. That's what your exponent is going to be. And because this number was less than 1 when we started, it's going to be negative. So we have our factor, 5.61 times 10, and then our negative, because it was a tiny number, and then 6, because that's how many times we moved it. All right. This one here, we moved it 7 times to the left, bigger than 1. 4.51 is between 1 and 9.99999 times 10. And again, positive because it's greater than 1. 7 because that's how many times we had to move the decimal to get a number in between 1 and 9.99999. So we're going to go to the book. We're going to be able to write numbers in scientific notation. And we're going to start not on page 74 because that's baby and we're beyond that. We're going to start on page 75. And they hate us. Oh, I lied. Yeah, 75. We're going to start at the top here. We're just going to do a couple examples of each. Oh, I'm glad this is here. Most calculators cannot obviously write these numbers in scientific notation. I'm sorry. Sometimes they don't have a way of expressing numbers in scientific notation. So you're going to see this little E here. This E stands for exponent. Okay. So if you see an E on your calculator, that's its way of saying this is like how it reads scientific notation. So this, it would be 3.5 times 10 to the 15. Same thing here. This would be 8. E is basically saying this is, holy cowbells, I'm so popular tonight. This is saying 8 times 10 to the negative 9. So a lot of times your calculator, if you see the E, because it can't show you times 10 to the whatever, that's what it looks like on a calculator. So I'm I'm glad that came up because I would have forgotten to tell you, and then you guys would have seen E and you'd have been like, what does that even mean? That's what a couple examples. It could look different ways. It tells you here sometimes it's even EE. So that's how calculators express scientific notation.